All right, today we're diving into one of the biggest claims in modern computing history. A few years back, Google announced that they had solved a problem in just over 3 minutes, a problem that would take the world's most powerful supercomputer 10,000 years to figure out. So what does that actually mean? Let's get into it.
To really get what a big deal this is, we first have to wrap our heads around the problem itself. This wasn't just some hard math equation. No, this was a challenge that was specifically designed to be, for all practical purposes, impossible for the computers we use today. I mean, just let that number sink in for a second. 10,000 years. That's longer than all of recorded human history. It's wild. Imagine you kick off a computer program today and the progress bar won't hit 100% until sometime around the year 12,024. That's the mind-boggling scale of impossible we're dealing with here.
And this is where it just gets staggering. You've got the world's #1 supercomputer at the time, a beast of a machine called Summit, needing an estimated 10,000 years for this one task. And then you have Google's quantum computer, Sycamore, which they claim did it in 200 seconds. That's the kind of jump we're talking about. It's not just faster, it's a whole different ballgame.
Now this sounds like something straight out of a sci-fi movie, right? But it's not. This incredible achievement is the very real finish line that researchers have been sprinting towards for decades. And it has a name: quantum supremacy. It signals a massive shift in how we think about computation. So what in the world is this new kind of machine that can pull off such an incredible leap? Well, to answer that, we have to dive into the kind of weird and wonderful world of quantum mechanics, where all the computing rules we know get thrown out the window. Yeah, I mean, how is that even possible? It's the first question everyone asks. How can one computer be that much faster? The secret sauce is in the absolute most basic building blocks of computing. It's all about the difference between a bit and what's called a qubit. Think about it like this. Your laptop, your phone, they all run on classical bits. A bit is super simple, like a light switch. It's either on, a 1, or it's off, a 0. That's it. But a qubit, a quantum bit, now that's a different beast entirely. It's more like a spinning coin. While it's in the air, spinning, is it heads or tails? Well, it's kind of both at the same time. That state is called superposition. And because it can explore all these possibilities at once, its power just grows exponentially.
And that ability is what leads us to the whole idea of quantum supremacy. Let's be clear, this isn't about a quantum computer being better at, say, browsing the web. Nope. It's about finding one super-specific, almost custom-built problem that it can solve, while the best classical computer on the planet just can't. Not in any reasonable amount of time, anyway. It's all about proving the concept.
All right, so now we know the rules of the game. Let's get to the moment it all went down. Back in 2019, Google published a paper, and trust me, it sent shockwaves through the entire world of computing. So here's the play-by-play. The team was Google's AI Quantum Group. Their machine, a 53-qubit processor they called Sycamore. And the task they gave it was, well, it was a weird one. Basically, they had it check if a bunch of numbers produced by a quantum circuit were truly random. It's not something you'd do in the real world, but it is incredibly, ridiculously complex. And the claim they made was just huge. 200 seconds for Sycamore, 10,000 years for the world's best supercomputer.
I mean, that sounds like game over, right? A total knockout. The moment everyone would pop the champagne. But science doesn't really work that way. There's always a skeptic, and in this case, a very, very big rival was about to step into the ring.
And that rival was IBM. Yeah, another heavyweight in the computing world. They came back with their own paper, and their argument was basically this. Hang on a second, Google. Your 10,000-year estimate is way off. They said that with a smarter approach, you could get that same supercomputer to solve the problem in just 2.5 days.
So this is really the heart of the debate, right? You've got Google's massive 10,000-year claim on one side, then you have IBM's rebuttal, bringing it way, way down to just 2.5 days. That's a huge difference. But here's the thing. Even if IBM is 100% right, look at the quantum computer's time. 200 seconds. 2.5 days is still a heck of a lot longer than 200 seconds. The quantum computer was still, without a doubt, way faster.
So where does that leave us? Honestly, getting bogged down in the 10,000 years versus 2.5 days debate kind of misses the bigger picture. Because no matter which number you believe, something truly fundamental and powerful just happened.
Look, the whole point of this experiment was never about solving a random number problem. That problem was just a test, a benchmark. Think of it like the Wright brothers' first flight at Kitty Hawk.
That plane didn't carry any passengers, it didn't fly for very long, just 12 seconds, but it did one incredibly important thing. It proved that powered flight was possible. That's exactly what the Sycamore experiment did for quantum computing.
And what it proved is that we're officially on the road to a quantum future. This quantum supremacy thing, that's just step one, proving the concept. And hey, check, we're there. But the next steps are massive. We have to build machines that are stable and don't make errors. That's called fault tolerance. Then we need to actually write the programs and algorithms for them, and only then can we start pointing them at the really big, unsolvable problems.
And you might be thinking, okay, that's cool for scientists, but why does it matter to me? Well, the potential here is just staggering. We're talking about the ability to design brand new drugs and materials molecule by molecule, creating financial models that are way more advanced than what we have today, and unleashing breakthroughs in AI that could solve problems we haven't even thought of yet. These are the kinds of grand challenges that quantum computers could finally help us crack.
So when you look back at Google's Sycamore experiment, don't think of it as the end of the story. Think of it as the starting pistol for a whole new race. The first big battle in this quantum quest has been fought, and arguably won. It proved we've built a totally new kind of tool, and that leaves us with this incredible, thrilling question. Now that we have it, what immense challenges are we going to solve next?